This last recorded lecture is going to focus on the major arteries and veins of the human body. So the cardiovascular system, just as a review, is divided into the pulmonary circuit. The pulmonary circuit begins at the right ventricle and ends at the left atrium. The systemic circuit begins at the left ventricle and ends at the right atrium. So that's important to know. You can look at the pattern of circulation here. So right ventricle is going to pump blood to the lungs, and then the blood's going to come back to the left atrium. This is your pulmonary circuit from the right ventricle all the way back to the left atrium. Then from the left ventricle all the way back to the right atrium is the systemic circuit. And this diagram shows some important structures. Let's see. I'm just going to do this one starting at the top left of the page. So we have the ascending aorta, the superior vena cava. This whole thing is the right lung, which has 3 lobes. The right pulmonary arteries that you can see, I will say they branch from the pulmonary trunk. So pulmonary trunk branches into the right pulmonary arteries. And they are blue because these are the only arteries in the body that are carrying, the pulmonary trunk and the pulmonary arteries are the only ones that are carrying oxygen-poor blood, because they're carrying oxygen-poor blood to the lungs to pick up oxygen. So most arteries are carrying, transporting oxygen-rich blood. Okay. Then we have the pulmonary veins, which are red because they're taking blood back to the heart, to the left side of the heart. That is oxygen-rich. So they're the only veins that are oxygen-rich. Okay. Then over on the right side of the page, we had the ascending aorta, the aortic arch, and we have the pulmonary trunk, which I already mentioned, the left pulmonary arteries, the left pulmonary veins, the left lung, which only has 2 lobes. And then if we take just the tip of one of these, well, it doesn't show the bronchioles, but anyway, the tips of these pulmonary arteries, they would become pulmonary arterioles, and then they would be capillaries. Okay, so the capillaries are associated with the alveoli. So this individual structure here, this one too, is an alveolus, which is an air sac. The air sacs are surrounded by capillaries. So that shows you how oxygen and carbon dioxide are exchanged between the capillaries and the alveoli. And then you also see here the descending aorta and the inferior vena cava. So I know you do have a lab activity where you have to know those structures of the pulmonary circuit. All right. Okay, so we have the major arteries of the body. We're going to start with the vertebral artery, the right common carotid artery, and the carotid arteries, remember, are the ones that where you can put your fingers up against your neck and feel your pulse. Then we have the subclavian artery. Clavian refers to clavicle. It's up here near the collarbone or the clavicle. Subclavian artery. The brachiocephalic trunk, which is the right branch off of the aortic arch, and then it's continuous with it, it becomes the subclavian artery. So brachiocephalic trunk, subclavian artery, which then becomes the axillary artery. Okay. Then we have in the upper arm the brachial artery, and we have the radial artery along the same side as the thumb, and the ulnar artery along the same side as the pinky. We have the palmar arches and the digital arteries in our fingers. And then let's go ahead back over here to the left side. We've got the left common carotid artery. And what is not showing is this branch would be the left subclavian artery. That's not identified, but it's the left subclavian artery, which is the left branch of the aortic arch. We have the descending aorta. We have the diaphragm, which of course is a muscle. Then we have the celiac trunk, the renal arteries, gonadal arteries, lumbar arteries, common iliac, and then the common iliac becomes the external iliac, but then a branch of it is the internal iliac, that's smaller branch here. All right, we have the deep femoral artery and then the femoral artery, which follows along the femur or thigh bone. We have the popliteal artery, the posterior tibial, which is lighter in color because it's posterior to the tibia. We have the fibular artery, the dorsalis pedis, the plantar arch, and then the anterior tibial artery. So the veins are pretty much the same. A couple of ones that I want to mention to you. The brachiocephalic trunk supplies the head and the arm. It branches to form the right common carotid artery and the right subclavian artery. The left common carotid supplies the head and the brain, and the left subclavian supplies the left arm. So I would say here, just make sure you know the brachial artery, because that's the one that is used in taking your blood pressure. And you can see the branches of the aortic arch, the brachiocephalic trunk here, the left common carotid, and then the left subclavian arteries. Okay. And then this one shows you really clearly the carotid, the common carotid artery, and we can see the external carotid artery, and this would be the left side. Everything over here is the left. And the internal carotid artery. So it's the external, it was the common carotid artery that where we can measure our pulse at the neck. Arteries of the trunk. I'm just going to skip this. Okay, so let's do the veins. I just mainly want you to know the major ones. And they're going to be real similar to the arteries, except you don't have jugular arteries. You have jugular veins and carotid arteries. They're analogous to each other. The vertebral vein, the external jugular, the internal jugular. Then you have the subclavian veins. You have the one on the right, the one on the left. The brachiocephalic vein branches into the subclavian veins. Then you have the axillary veins. You have the cephalic vein, the brachial vein, and the basilic vein. So so you see the brachial artery, but you don't see the cephalic and the basilic. You have the radial vein, the ulnar vein, and then we have one called the median antebrachial vein. Now, what I want to find is the median cubital vein. That's probably in a different diagram, but it's going to be in this area here. Okay, then we have the palmar venous arches, the digital veins. We have the great saphenous vein. We have the popliteal, small saphenous, and fibular, plantar venous arches, dorsal venous arch. We have the superior vena cava, the intercostal veins, the diaphragm, inferior vena cava, the renal veins, gonadal veins, the lumbar veins in the lumbar region of the back. Then we have the common iliac, which forms into the external iliac, and then a little tiny branch is the internal iliac. We have the deep femoral vein, the femoral vein. We have the posterior tibial and the anterior tibial. And I think that about does it. One significant difference, here we go, between the systemic arteries and veins is the distribution of veins in the neck and limbs. Oh, that's not what I was, okay, but So we have jugular veins and we have carotid arteries. So that's one thing. Here it is. The median cubital vein is where we collect blood samples in the process called venipuncture. And here it is. There we go. Median cubital vein. Right there in the bend of your elbow. Now we have checkpoint questions, and I think this is it. So, because, yeah, this is going to be it. A blockage of which branch of the aortic arch would interfere with blood flow to the left arm? And that's going to be the left subclavian vein. And then why would compression of the common carotid arteries cause a person to lose consciousness? Well, because that stops blood flow to the brain. Grace is in an automobile accident and her celiac trunk is ruptured. Which organs will be affected most directly by this injury? So basically that celiac trunk is going to branch into arteries that serve the stomach, the spleen, the liver, and the gallbladder. That's about the area that the celiac trunk is in. Okay. See if there's anything else that I've highlighted. Oh yeah, okay. Age-related changes in blood. You're going to have a decreased hematocrit, formation of a thrombus or stationary blood clot, which can become an embolism. If it's in the lung, we call it a pulmonary embolism. And that, of course, that can lead to death. Another thing that happens with aging is the pooling of blood in the veins of the legs due to ineffective venous valves, and that leads to varicose veins. And we have, in the heart, we have progressive atherosclerosis, or plaque formation in the heart, in the coronary arteries. This can restrict coronary circulation and lead to coronary artery disease and heart attack. Atherosclerosis, which is plaque in the arteries, can lead to arteriosclerosis, or thickening and toughening of the arterial walls. So they're related. And this can lead to a local bulge called an aneurysm. Rupture of an aneurysm could lead to stroke, myocardial infarction, or heart attack, and then significant blood loss. And that is it for the cardiovascular system.